Hello everyone. In this video we're going to be solving a functional equation. We have f of 5 minus x equals f of x minus x squared divided by 2, wherever this function is defined. And we're supposed to evaluate f of 4. So when you're given an equation like this and you're supposed to evaluate f of something, usually you try to replace x with that value, or you use an x value that will give us what we want, right? So in this case, it would make sense, since I need f of 4, why don't we let x equal 1, right? In that case, we're going to find f of 4 equals f of 1 minus 1 squared divided by 2. Great. Even though this gave us f of 4, somehow we also got another variable, which is f of 1 at this point. So we kind of need to do something for that. How do I find an equation that contains f of 1? If you look at the original problem, it makes sense if you replace x with 4 now, right? Okay, great. So if we do that, we're going to get f of 1 equals f of 4 minus 4 squared, which is 16, divided by 2. So now I got two equations and two unknowns. That is a system. By solving that system, we're going to be able to find f of 4. Great. Now, how do you solve this system? That's the million-dollar question, right? Well, I can use substitution or I can use elimination. Let's go ahead and cross-multiply both of them. So the first one is going to give us 2f of 4 equals f of 1 minus 1. And then the second one is going to give me 2f of 1 equals f of 4 minus 16. Since I'm looking for f of 4, it makes sense to get rid of f of 1, right? So again, we have two methods here. Let me introduce both, substitution and elimination. Let's go ahead and start with substitution first. So to substitute, and since I'm looking for f of 4, it would make sense if I could isolate f of 1. So f of 1 can be written as 2f of 4 plus 1. Now I can go ahead and substitute that here. Make sense? So let's go ahead and replace f of 1 with 2f of 4 plus 1, and that equals f of 4 minus 16. Since the only variable is f of 4, we can solve for f of 4 here. And if you don't like the fact that I keep saying f of 1 is a variable, f of 4 is a variable, you can replace f of 1 with a and f of 4 with b, and then just solve for b. Let's go ahead and distribute 2 times f of 4 plus 2 equals f of 4 minus 16. If you subtract f of 4, you get 3f of 4 equals negative 16 minus 2 is negative 18. And from here, you get f of 4 equals negative 6. Make sense? Okay, great. So that gave us the answer. Let's go ahead and rewrite our system and take a look at another approach. So we have 2f of 4 equals f of 1 minus 1. And the other one is 2f of 1 equals f of 4 minus 16. Awesome. So we have these two equations. Again, that's a system, and I would like to use elimination. So here's what I'm going to do. I'm going to go ahead and multiply both sides of the first equation by negative 2. And that kind of makes sense, because if I'm trying to solve for f of 4, I'd like to get rid of f of 1. The coefficient of f of 1 here is 2, and the coefficient of f of 1 here is 1. So I need to kind of make him disappear. So I will multiply the top equation by negative 2. That's going to give me the following. Let's go ahead and rewrite it. And this time I want to write this on the left-hand side. So let's distribute negative 2 f of 1 plus 2, because negative 2 times negative 1, equals negative 4 f of 4. So I switch sides. And the second equation stays the same. 2f of 1 equals f of 4 minus 16. Notice that by adding these equations side by side, I'm able to eliminate f of 1. And this gives me 2 equals negative 3 f of 4 minus 16. If you add 3 f of 4 to both sides and subtract 2, you're going to get the following, and from here we're going to be getting the exact same solution. Awesome. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, Happy New Year, and Bye bye.